All right, good morning everyone and welcome. This is going to be a talk on TLS 1.3, the support we've added in Java most recently. So this is available in JDK 11. My name is Brad Wetmore. I am one of the engineers that works with the Java Security and Libraries group. To my left, or your right, would be Xue-Lei Fan, not Chen, Fan. And he was one of the persons who worked directly on a lot of the implementation details. So hopefully any questions that you might have at the end, we'll hopefully be able to answer. So of course the mandatory safe harbor statement. So one of the things I'd like to do is just give a quick introduction to the TLS and SSL because some people may or may not be familiar with it. Actually, that's a good question. How many people are familiar with SSL, TLS, have a working knowledge of it? How many people are experts in it? A couple, okay. And do we have any open JDK developers who might be interested in doing TLS development? Okay, so I'll skip the last part. So what is TLS and SSL? Well, TLS, I've already mentioned, is the transport layer security. SSL is the older version of this called the secure socket layer. And what it really is a secure communication channel between two peers. The features that it has are it supports authentication, so the peers can identify themselves to each other. There's confidentiality, which is where you have the data encryption, and it hopefully will prevent disclosure by people who are not supposed to be looking at this stuff. And then also integrity protection, which is adding some kind of a checksum or a hash mechanism so that people can't say, you know, transfer $5 instead of $5,000. There's two main components of TLS. There's the handshake protocol, which is what we use to authenticate the parties and negotiate the crypto modes and all the keys that go along with it. There's also the record protocol, which once all that has been negotiated, then we take that and segment the data into bite-sized chunks and send that using the information we've just, excuse me, stupid phone. So we can use that to protect our data. So where does this fall in the network stack? Well, it's pretty straightforward if you're familiar with the old network diagrams. We've got the network layer, above that's the IP layer, above that's the TCP layer. So SSL and TLS require a connection state-oriented transport protocol, and so that's where that fits on top of there. And then clients like HTTP or other applications can use those in order to send their information to and from the server or client. So the key fundamentals, the processes that we go through and the types of algorithms we use are threefold. The first is a key exchange or a key agreement algorithm. And this is using asymmetric encryption using public and private keys. The problem with asymmetric encryption, of course, is that it tends to be slow. So what we usually do is we use this to negotiate a faster key that we can use a little bit later on. But we can use this for things like certificates, where we can actually use public and private keys within certificates to identify who you are. So some examples of that are RSA, Diffie-Hellman, and then there's another variant of that called elliptic curve crypto Diffie-Hellman, and so on. Once we have the key exchange or the key agreement happening, then we can go to the cipher step. And the cipher step is where the bulk of the ciphering operations are going to be occurring. So that's going to be fast, much faster. We're going to use the keys that we used in the previous step. And some examples of that are everyone's favorite now, AES. There's the old triple DES or DES-EDE standard, which is kind of falling out of favor. RC4, please don't use. There's the old DES, please don't use, definitely don't use, and so on. There's also the message authentication code, which is like the hash or the checksum that I mentioned a little bit ago. It's essentially a hash and checksum with some private state that's initially derived also from the key exchange and key agreement algorithms above. So some of those are based on MD5, SHA-1, SHA-256, 512, 384, and so on. So how TLS operates, you have a client, you've got a server and some network in between them, and you want to be able to have them interchange information. So we start by doing a connection and then a key exchange or a key agreement operation. And then that sets up the keys. And then once the keys are set, then we go ahead and we feed those into the ciphers. And the ciphers are then what do the confidentiality. From there, of course, we also then initialize the MAC operations or the message authentication code, which then takes care of our integrity protection. Once those steps have all been done, then we take each of those operations and we enclose that in a network packet, and that's what we actually ship out over the network. And then the other side will then do the things in reverse. So just really quickly, the SSL version 3 and TLS 1.1, 1.0, and 1.2 handshaking messages kind of look like this. We have a client hello. The server says, oh, hi, client. Here's my server hello, and we're going to exchange what kind of operations we're going to use. We're going to choose the cipher suite, what protocol version number, and so on. After that, the server will send its certificate and say, hey, I'm Amazon.com. And if I need to, then I may request a certificate from your side. I may send some key information, and then I'll send my hello done. The client then responds back, maybe with a certificate if it was requested. It will also send some key exchange information that will be used, either key agreement or key exchange. And then maybe a certificate verify message. And then at that point, we have this change cipher spec. And after that, everything goes dark. So what I mean by dark is it's all encrypted. So anyone snooping on the wire can't see any of that stuff going across anymore. So notice there are two complete round trips that take place here. We have the client hello, server hello, and then the certificate, and then the change cipher spec, and then it comes back from the server as well. So two complete round trips. So that becomes a little important here in just a little bit. So I'm going to really briefly touch on some of the historical highlights. There was an original version of SSL version 1, which Netscape never released. Then there was a version 2, which had a few things that were problems. There's great information on the web if you want to learn about more what was in these things and what some of the limitations were. SSL v3 was the first one that really caught on. It was also developed by Netscape, and it was documented as RFC 6101, if you want to go back and look at it. But at that point, there started to be a little bit of a fork, and Microsoft came up with a competing protocol, which was based on this SSL v3, and they kind of forked things off a little bit, and so you had this competing dichotomy between the Netscape folks and the Microsoft folks. And so at that point, IETF got involved, and they decided that they were going to standardize a new protocol. We'll call it TLS to change the name. And that was standardized as RFC 2246. And it's very similar to SSL version 3, but not interoperable. But it did take a long time to get the consensus because there were some competing factors that went on as well. As that came out and became more used, about 7 years later, somebody said, oh, wait a second, there's a problem with the way that you guys are doing your encryption, and maybe we should take care of that. And there was a cipher block chaining issue that becomes important a little bit later. So it took care of the IV attacks, initialization vector attacks, and so also some padding attacks. Then fast forward another 2 years, and then version 1.2 also came out, which is based on 5246. And that did a whole bunch of cleanup that they wanted to do in 1.1, but just didn't have time for. So that included things like pseudo-random functions that were adjusted. The MD5 SHA-1 combo was no longer used. We're using some more modern algorithms there, and so on. And it's currently the best practice. So why TLS 1.3? Well, if you remember back, I just said it was like 2008. Did I say 2008? Yeah, 2008. So it's been 10 years. There was a bunch of minor issues that popped up, and every now and then there's a protocol hole. And okay, well, we have these things called extensions. We'll use extensions to plug that hole. So we came up with a new RFC, and well, lo and behold, there's another problem. So we'll throw another RFC at it, and then another one. So it just kept going on, and then all of a sudden Poodle hit. And Poodle is a vulnerability that for at least SSL version 3, we couldn't fix just because there was nothing we could do to have a RFC that would fix it using extensions. So after 25 years of vulnerability research, beasts and poodles and freaks, oh my, they decided that it's really time that we need to update this protocol. And so there were lots of really fun named attacks. I'll just throw out a whole bunch of them here just to overwhelm you really quickly. So there was beast, crime, breach, poodle, bar mitzvah, freak, logjam, sweet 32, just lots of fun stuff. So at that point, 1.3 was starting to get underway. There's also some of the older protocols are just, we just can't use them anymore. Version 2 was prohibited in 2011 by RFCs. SSL version 3, after Poodle came out, it was also a problem. SSL version 3, there's just really no acceptable record protection anymore because CBC is kind of bad. RC4, it has these biases. We're not going to use that anymore. So really nothing that could be used for record protection. And there's also no extensions in SSL v3, as I mentioned, so we couldn't even do some protections there. Also, TLS 1.1 and 1.0 are also being rapidly phased out. There's now an internet draft out, which is basically saying, the name of it is Draft Morty TLS Old Versions Die, Die, Die. So that gives you an idea of what the community would like to do with these older versions. So the community is starting to really work on it to be phasing out TLS 1.0 and 1.1. Microsoft has announced that they're going to be phasing it out in the first half of 2019 from their browsers, from Edge and Internet Explorer. Chrome is targeting January 2020, Firefox and Safari March in 2020. Some other folks that are getting rid of TLS 1.0 and 1.1 include the payment card industry. There was a big thing back in June where everyone jumped off of TLS 1.1 and 1.0, and at least my bank was saying you can't use these browsers anymore. So there's also HTTP 2, which was finalized last year, if I remember right. It requires TLS 1.2 or 1.3. You can use 1.2 with some blacklisted cipher suites, but they would prefer you be on 1.3, I think. There's also some 5G wireless standards that are out there. NIST and GitHub, everybody's turning off 1.0 and 1.1. So it's time to start upgrading at least to 1.2, if not to 1.3. And the other thing is TLS 1.2, 10 years old. So it needs updating with a lot of the latest crypto advancements and practices that have occurred over the last 20 years or so. So talking now a little bit more about the details of 1.3. So at the RFC level, how does it differ between 1.2? So about 4.5 years ago, the IETF TLS working group produced about 28 different drafts over 4.5 years. So it was a lot of change, a lot of ideas that worked and didn't work, and eventually they came up and standardized on RFC 8446 back in August. It's a pretty major overhaul. There's so many things that have changed, but the two primary advantages that you can kind of distill it down to are increased security and improved speed. So for the security side, less is safer. They wanted to get rid of some of that old broken stuff. For example, no RSA key transport. And we'll talk a little bit more in detail about this, but if you're familiar with the term forward secrecy, that's one of the reasons that RSA key transport is no longer allowed. We're getting rid of the old CBC or the cipher block chaining modes. We are getting rid of the RC4 ciphers, the SHA-1 hash functions are all gone, and so on. We're now favoring SHA-2. The arbitrary Diffie-Hellman groups, we used to just say, you know, here's a group that you can negotiate. That's all gone as well. It's now a specific set of Diffie-Hellman groups. And also to clean up some unsafe features that proved dangerous at the time, things like compression and renegotiation. So to enhance that security, we're going to use some more modern algorithms, things like the PSS, which is part of PKCS1, the latest version of that. Cha-Cha-20 and Poly 1305. We are in the process of doing that. We haven't got everything yet, so it's not in 11, but we'll talk about that more later. There's also some new curves, which have some wonderful security properties. Those are called 25519 and 448. Those are elliptic curves that have nice properties that can be used here. And then there's also some negotiation and downgrade protections, as well as much more of the handshake is protected. And we'll talk about that here in a second. So on the left-hand side is the slide I showed you a little bit earlier. Now, this is the new TLS 1.3 slide, or the 1.3 handshake on the right-hand side. And if you notice, we have a client hello and a server hello still. So the client sends its hello message and says, these are the things I want to use. I want to maybe do 1.3 or 1.2. Here are the cipher suites I want to use, and so on. But what's different here is we now actually start sending the public keys from a, say, a Diffie-Hellman key exchange, key agreement, excuse me. And so it'll actually send its keys in the key share in the beginning of the message, which is important in a second here. There's also, if you want to resume a session, there's pre-shared keys that we can use. Then the server hello says, okay, well, here's the cipher suite we're going to talk, and here's the version of the protocol we're going to use. And then, surprise, everything goes dark. So now the rest of the handshake is all encrypted. So there's some extensions that go on that used to be part of the server hello, the certificate request, certificates, and so on. And then notice there's a finish message. It appears almost immediately, not like in the old one where it appeared at the end of the second round trip. And then the client can send its certificate and certificate verify and then send its finished message and so on. So the thing that makes this nice is that instead of taking 2 complete round trips, now only 1 complete round trip is required before you can start sending data. So that kind of hinted at this already. The TLS 1.3 can use 1 round trip without using pre-shared keys. Or there is a mode by which you can use 0 round trips. So you basically send your client hello and then immediately start sending data. But that has some questionable attributes right now, and they're still trying to get that straightened up. So as I mentioned, the shared secrets are derived earlier, and there's some more effective key exchanges. So after all that, we're now ready to talk about TLS 1.3 in JDK. So the JDK implementation in JDK 11, we did do a version of 1.3. And the goal, of course, is to have an interoperable TLS 1.3 implementation with all the required features. There's a bunch of things that are optional, but we wanted to make sure we got all the required features done first. So we have a bunch of new algorithm names. For example, SSL context, you would now say get instance of TLS version 1.3. There's new protocol names as well. So when you're setting your enabled protocols, you would use TLS version 1.3 as well. Notice here the cipher suite names have changed. It used to be you had a TLS followed by the name of the key exchange, followed by the cipher, followed by the PRF values. We've gotten rid of the key exchange part, so, or I should say we, IETF did. So the cipher suite names are completely different than they used to be in TLS 1.2 and earlier. We'll get into that in a minute. On June 25th, we finished our implementation and we integrated it into JDK 11, and it was about 54,000 lines of TLS implementation code, as well as some other stuff that we added for makefiles, tests, and so on, and that took us to about 70,000 lines. So it was a fairly involved process. It was, of course, developed under the Java Enhancement proposal process, or the JEP process, so anyone who's familiar with OpenJDK development knows what this is. It was done under JEP 332, and there was a couple of other things that we added the JCE, or the crypto components, but we haven't actually plugged the JSSE part into. And that includes things like the 25519 curves and also the Cha-Cha-20 algorithms. So those were developed under different JEPs. And everybody's seen the brick wall diagram, I'm sure. This is the one for the security side. So of course our JSSE is here, and most everything that we did was under 332, but there's also 324 and 329, which are at the moment just for JCE. Next year I hope to be back and we'll actually have those in the middle as well. So how to use TLS 1.3? This is the big one here. If you have been using the get default methods, you're done. It's easy. It's all default enabled. So all you have to do is say, give me an SSL socket factory, get default, and it's already enabled. Same thing if you just want to use the SSL context to maybe create an SSL engine. Just give me the default. Or you could actually just say TLS, but that eventually refers back to the default. So everything is all set up for you. If you're a new fan of the HTTP 2 mechanism, that's the default as well. Now, if you were one who likes to include specific versions of your protocols, well, you've got a little bit of work to do here. So if you have before said, you know, give me an instance of TLS 1.2, well, now you're going to have to say, give me TLS 1.3. If you gave a specific context or a protocol or a cipher suite and you need to do the same thing, you need to update it to the new values. So before we used to say TLS ECDHE, ECDSA with AES 128, blah, blah, blah. That's the old style. If you want to use the equivalent, then you have to use the new protocol names, cipher suite names, excuse me. And that applies whether you're using the system properties for HTTPS, using the HTTPS URL connection, or if you're using SSL parameters and you want to hard code those values into your socket or engine. Where are we in the features? Well, the required things, the handshake model wasn't really required, but we did it anyway because it made everything else a lot easier to implement. The HKDF, it's a key derivation function based on hashes. That was required. Finite field Diffie-Hellman exchange is also required, but that's actually been backported into earlier versions. The key usage limit, which allows you to specify how much data is encrypted before you change keys, and as well the RSA PSS. Those are all required. We had to update those for JDK 11. There's a bunch of optional features which we'd like to do at some point. We are looking for CCM. I don't think EDDSA will make it into 12, but we're going to shoot for it soon, and so on. There's a bunch of other things that we want to make sure that we get in. There's extensions galore. Just realize that we have done all the mandatory ones. There's a few that are optional that we've had in place for a couple years now, including ALPN, which was kind of significant. But some of these we do, some of these we don't. There's some new configuration properties. There is an existing way to set the default protocol on a SSL context, and that is using the JDK.TLS.client.protocols system property. And so normally you just say, give me TLS version 1.2 or whatever. Now you can just say add 1.3 and everything will be updated for you. We now have a server-side system property as well, so not just on the client side, but now on the server side. There's also a new security property, which you update using the java.security file. And that allows you to specify how much data can be encrypted before we need to change keys around. And then everything will be re-handshaked and updated for you. So for debugging, debugging has completely changed. So if you've written some code that depends on the format of the debugger, you've got a little bit of work to do. We're also outputting things in system.error rather than system.out. As you can see, the format looks very different. I think it's a little bit easier to parse and read. I guess that will be seen. If you are interested in seeing a worked example in the new format, please consult the JSSE reference guide. I did a long section there all about the different messages and what they look like. So that's a good place to start. Some more enhancements that I'll just kind of breeze through here. We've removed some of the unsafe KRB5 cipher suites or Kerberos cipher suites. They're pretty much phasing out at this point. There's also the stateless hello retry request, which is used by the server if the client sends parameters that it just doesn't like. We have also implemented as much as we can for compatibility, and so we followed most of the recommendations that took place in 8446 Appendix D. So we do things like sending a non-empty session ID, which is an old field that used to be used in earlier versions. We also support the cipher change cipher spec, which will help in compatibility as well. So speaking of compatibility, as you're doing your code, it might be that you had depended on a specific way that TLS used to operate in the past. There's been a couple changes in that area as well. TCP, if you're familiar with, you have half-closed feature on sockets, where if the client is done talking to the server but it still wants to read data, it can just go ahead and say, I'm done, fin. And the server can just keep sending stuff until it's all done. So the server will send an ACK, and then it will continue sending its information. And then eventually the server says, OK, I'm done. Here's my fin. And the client responds, of course, with an ACK. So in SSL version 3 and TLS 1.0 up to 1.2, there is no such thing. Once the close notify is sent by one of the peers, the other side has to shut it down immediately. So that has changed in 1.3. So we have a close notify. The server can continue to send data, and then eventually when it's done, it can send the close notify. So for your code, you'll need to update that to close both sides. So it's a duplex policy in 1.2. In TLS 1.3, it's a half-close policy. If you want the old way, you just don't like the way that they did that, we did provide a compatibility switch, and that is JDK.TLS.acknowledge close notify. And that will hopefully bring you back to the way it was in previous JDKs. TLS 1.3 also has a very tightly defined set of key exchange and key signature algorithms that were used for things like certificates. In TLS 1.2 and earlier, it was very fluid and very not well defined. You could have this type of algorithm, and you could mix and match any way you wanted. In TLS 1.3, it's very specific. You can only use this algorithm with this algorithm, and there's a defined list. So if you were depending on that previous behavior, you may start running into problems as well. So just a heads up on that. One of the other things that's it's been catching a lot of our customers by surprise is that DSA is deprecated. No more DSA in TLS 1.3. So if you are depending on a DSA certificate for your identification of a handshake, it's not going to work anymore. So what you need to do is update to either an RSA key or some kind of elliptic curve key. You might need to get a new certificate for you. Also, the SHA-224 based certificates, signature algorithms are also deprecated. Some countermeasures, if you really need to have this stuff and TLS 1.3 isn't for you, I already mentioned these up here, and that's to set these system properties, and that'll set the defaults back to 1.2. But we encourage you, of course, to move to 1.3 because it's much more stable and much quicker. So I mentioned a little bit earlier that RSA key exchange is bad. Now I'm actually going to go into why that's bad. So if you look at the handshake that we had earlier, we have a client hello, server hello. The server says, here's my certificate. And let's say the certificate has the server's public key in it. And it sends the certificate across, and the client then says, oh, OK, I'm going to choose this session key that I'm going to encrypt using that public key, and then the server can decrypt it, and we'll use that as the entire basis of our encryption. So the session key is initialized on the client side. It's then sent to the server side as encrypted data. The server decrypts it, and then it uses that session key, the same session key, to initialize all the crypto, so now everyone is all synced up. This is all great, except let's say that you are a middle box, or you have some monitoring software or monitoring tools and so on, or maybe you're a government agency that likes to grab all the traffic coming off of the network and store it for later time when you may need to analyze it. So we'll just snoop all the connection and we'll dump it into some kind of database. And then at some point, if that private key is ever compromised on the server side, what happens? We know exactly what that session key was because we can work backwards and start with the encryption that was done and sent across to the server. So as long as we've got that server's private key available, the network traffic is now vulnerable. So RSA is now not allowed. And that caused a lot of screaming and gnashing of teeth when RFC was just about to go final. But that is the way it was finally implemented. There have been some proposals for doing some kind of key escrowing. We're back to the early 2000s. But at this point, this is the way it is. So the status of TLS 1.3. NSS, OpenSSL, everyone is working on their implementations. Those two that I just mentioned, they actually do have their versions out, and those are available for inclusion in your apps. GNU TLS, last I heard, they're at draft 28. Triz and Cloudflare, they have a full RFC version, and Facebook is actually the largest, from what I understand, the largest version, largest user of TLS 1.3, and they've got their own implementation called Fizz. It's currently at draft 28, and almost 50% of their traffic is now using TLS 1.3, which is a fairly significant amount of traffic. In terms of the browsers themselves, a lot of them are still back on 28. They're just waiting to catch up with their internal libraries. So Firefox, I just checked on Friday, is still at 28. Chrome, I believe, is still at 28. But the Chromium changes that are necessary went in mid-August, so it won't be long before those are all running the final RFC. Opera depends on Chromium. The one I haven't heard much on the plans yet for a date is Microsoft. They're working on their S-channel, IE, Edge, mobile, and so on. That's all under development. I don't have a date, unfortunately, that I've heard, but if anyone has it, I'd like to hear it. And then Safari's also coming up, hopefully, with theirs as well. There's a site out there called Can I Use, which has got a bunch of different browsers and such that are available for determining what is supported and not. So for the interoperability and compatibility testing between the TLS 1.1, 1.0, 1.2, of course, we're doing all that. We're still doing all of our normal interoperability testing with all the different implementations, OpenSSL, NSS, Bouncy Castle, Firefox, Chrome, all the big guys. We're also doing some third-party compatibility testing with applications that use ours as well, like MySQL, Jetty, Netty, and so on. We found a few issues. They're being fixed as we find them. That's the nice thing about having the rapid releases is we can get those out pretty quickly. TLS 1.3 now on the regression and interoperability testing. Well, everyone is still finishing up their RFC implementations, so we're finding things as they are evolving. We are doing regression testing against our own stuff, of course. So we have some new TLS 1.3 test cases. We have the default versions is, everything seems to be working on the default side. HTTP client is using 1.3 by default. And then, of course, we're doing the interop testing as we're able to, so things like OpenSSL, Firefox, all the big guys. So kind of to wrap up and talk about futures a little bit here. What's next? Well, this was the first version, so we've got some implementation issues we've noticed, some performance problems, and we're working on those. We have some ideas on how we can maybe improve the behaviors of some of our things using some APIs, so that may be something for 13, 14, and so on. Of course, we would love to get to the CCM mode of AES, which is a counter mode. EDDSA, we have the information for, we have the work that we're doing for that. It's not all in place yet. Same with 25519 and 448, and Cha-Cha 20 and Poly 1305. For those last two, we actually have the JCE portions of them. We just don't have the JSSE portions linked to them. So that's to be done soon. There's also some signed certificate timestamping that we want to do. There's some post-handshake authentication that's available. Certificate authorities, there's some new stuff that we can do there, as well as OID filters. So beyond 1.3. So I mentioned in an earlier slide that Microsoft and Chrome and so on, they're all starting to sunset their 1.0 and 1.1. Expect the same from Oracle's Java side. We're going to be doing that in the next little bit here. There is a website that is, if you Google it, it's the Java Cryptography Roadmap. And so look for that, and it gives you all the information about what we're sunsetting and when. There's also efforts for DTLS 1.3. IETF is working on standardizing that. The last I've heard, they're still at draft 28, so it's got a little bit more to go. DTLS is basically TLS, but over an unreliable connection. So for more information, we have the OpenJDK, where all of our downloads are. It has the same features and performance as our Oracle JDK, but it has the GPL version 2 plus ClassPath license. For Oracle JDK, if you want to use the commercial version, that has the OTN license and requires a support contract. The docs, we've tried to be updating our docs based on the new information that we've been putting in. And so there's the doc links. You can also get to that from the normal download sites as well. And there is also a mailing list, but I would like to caution you, this is not for developer questions like how do I use JDK, how do I use JSSE, how do I get a 1.3 context. These are more for things like I've got a very specific question about how to implement this extension within the TLS protocol. How do I do this in JSSE? So we're really looking for OpenJDK developer type questions. For finding TLS bugs, if you find anything, there's two ways you can do it. Both of them require logging into either bugs.java.com, which is for most people, or if you have an OpenJDK developer ID, then you can go through and log into bugs.openjdk.java.net. If you're interested in more crypto, you hadn't had enough here, there is another session being led by Adam, who's down here, and he's going to talk about some of the high-speed cryptography changes that are coming in, specifically the 25519 and Poly 1305, as well as EDDSA. So that'll be in this room. As soon as you leave, you can come right back in. But that will be at 12:30. I know that was a lot of information, and I apologize. It's quite a bit to talk about. I do have a few slides if you want to look at the implementation details, but it doesn't sound like most of you are OpenJDK developers, so we can skip that part. But I wanted to see if there are any questions to start with. And Xue-Lei is also available for any questions. I'm sorry, I didn't quite hear the question. Can you use microphone? I'm sorry, there's microphones up here.
If you use a neutral TLS, would it make your story a little different because you're only showing surface difference here, for example. What if you use client?
It's not about two-way SSL.
Two-way?
Client
Client authentication. Sorry. It's pretty much the same thing. You just the server will send its list of CAs that it will like and the certificates types that it will like, and then it's up to the client side to look in its key manager and decide, okay, this is a good certificate we want to send across or not. So yeah, it should be pretty much the same thing. Are there other questions? All right, well, barring no further questions. Would people be interested in seeing a little bit of the implementation, or do you want to just skip? Sure. If they're using the default mechanism, then they're going to get it for free. If they are doing specific configuration, then they will need to use whatever mechanism to turn on 1.3. Yes. Yeah. Tomcat will need, or anything will need a Java 11. Yeah. Right. At the moment, we are looking into getting a backport, but at the moment we are not. We haven't announced any active work on it.
Yeah, I was concerned when I saw that chart of Firefox and all.
Yeah. Mm-hmm. Well, they'll still be supporting 1.2 for a while. Okay. Yeah. It's just 1.1 and 1.0 that they're trying to get rid of. Yep. All right. I didn't see any jumping up and down for implementation details, so okay. Thank you very much.